In mathematics, a quadratic equation is a single variable polynomial equation of degree 2. The values of x that satisfy the equation are called the solutions, zeros, or roots of the equation. In this video, we will study only quadratic equations with real roots. Hello everyone, welcome to my channel. My name is Rafael. I'm an electrical engineer and bilingual teacher of mathematics and physics from Brazil. And in this video, I would like to discuss with you 9 exam questions on quadratic equations. Let's go to the first exercise. Exercise 1 asks us, what is the sum of the roots of the equation x squared minus 4x times x squared minus 9 equal to 0. Okay, my friends, this is the exercise. Let's go to the solution. To find the roots of this equation, we can develop the product, okay? To find the roots of this equation, we can develop the product, multiply here and equal to 0. But instead of doing this, we will work on each term separately, alright? Instead of developing this product, we will work on each term separately. It is easier, I think. Thus, x squared minus 4x is equal to 0. Observe that if this is equal to 0, then this all is equal to 0, okay? But we can develop this. Let me factor out x times x minus 4 is equal to 0. Observe that we have something here, and this something is equal to 0. We want values of x here and here that make it true, that make it equal to 0. Observe that x equal to 0 makes this statement true. Alright, because if I multiply it all by 0, it is 0. But there is an additional value that makes this equal to 0. Alright, and this is the root of this equation. X minus 4 equal to 0, in which x is equal to 4. If I substitute 4 here, 4 minus 4 is equal to 0. Okay, 0 times any value here will be 0. Then we know that x equal to 0 and x equal to 4 are the roots of this equation here, okay? Let's do the same for this. X squared minus 9 equal to 0. We have something here, and this something is equal to 0. Alright? We can pass this 9 here. X squared is equal to 9. Alright? Now, it is not equal to 0 anymore. X squared is equal to 9. We have two values for which this statement is true. Okay? I pass this, and it becomes x is equal to, I pass this squared, it becomes the square root of 9. I have two values for this. The first is x equal to 3, and the second is x equal to negative 3. Okay? Consequently, x equal to 0, x equal to 4, x equal to 3, and x equal to negative 3 make this original statement true. Okay? If I substitute 0 or 4 or 3 or negative 3 here, this statement will be verified. It is true. Alright? Thus, the original equation can be rewritten as, let me erase here, and you see how to write an equation in terms of its roots. We can write this like this: x minus 4, x minus 3, x plus 3 equal to 0. If we had carried out this product here, we would find the same as performing this multiplication here, okay? The difference that this polynomial here is written in terms of its roots, and here not. And the exercise wants us to sum the roots. Let's sum the roots. We discovered that the roots were 0, 4, 3, and negative 3. Thus the sum is 0 plus 4 plus 3 plus negative 3, and this is equal to 3 with negative 3, they cancel each other out. 0 plus 4 is 4. Alright, my friends, a very easy exercise. Okay, instead of developing this, we found the roots, working on each term separately, and as the exercise requested, we summed the roots and we found the solution. Alright, my friends, this was exercise number 1. Let's go to exercise number 2. Okay, my friends, let's go to the next exercise. Let's go to exercise number 2. Exercise number 2 asks us, what is the greatest root of x squared minus 6x minus 16 equal to 0? Okay, my friends, this is the exercise. Let's go to the solution. And to find the roots of this equation, we may use the quadratic formula. Observe that for the equation ax squared plus b times x plus c equal to 0, we may use the quadratic formula to find the roots, okay? The quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a, okay? We shall use this expression to find the roots of this equation. Let's go. Let's do it. Consequently, x will be equal to negative b. b is negative 6. Then negative 6 is 6. Positive 6 plus minus the square root of b is negative 6. Negative 6 squared minus 4 times a. a is 1 times c. c is negative 16. Okay? c is negative 16 divided by 2 times a. a is 1. 2 times 1 is 2. Okay? Now, it's simple mathematics. We need to just calculate x is equal to 6 plus minus the square root of negative 6 squared is 36. Negative, positive. 4 times 16 is equal to 64. It all divided by 2. 36 plus 64 is 100. X is equal to 6 plus minus the square root of 100 divided by 2. And the square root of 100 is 10. Okay? X is equal to 6 plus minus 10 divided by 2. We will have 2 roots here. We have 2 signs here. Then we will have 2 roots. x1 is equal to 6 plus 10, 16 divided by 2 is 8. And x2, 6 minus 10 is minus 4, divided by 2 is minus 2. Alright? We therefore discover that 8 and negative 2 are the roots of x squared minus 6x minus 16 equal to 0. From the roots we see that 8 is the greatest root of this equation. Okay, my friends, this is all for exercise number 2. Let's go to the next. Let's go to exercise number 3. Exercise number 3 now, my friends. If m is the greatest root of 3x squared minus 4x minus 2 equal to 0, what is the value of 3m minus 2 squared? Okay, my friends, this is the exercise. Let's go to the solution. As it was done previously, we will use the quadratic formula. The quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a. Okay? For this expression, x is equal to negative b. B is negative 4. Negative 4 is positive 4 plus minus the square root of b squared. B is negative 4, then negative 4 squared minus 4 times a. A is 3 times c. C is negative 2. Okay? C is negative 2. Divided by 2 times a. A is 3. 2 times 3 is 6. Simple mathematics now. Let's work on this. X is equal to 4 plus minus the square root 4 squared, negative 4 squared is equal to 4 squared, which is equal to 16. Negative with negative, positive. 4 times 3 is 12, times 2 is 24. Divided by 6. 16 plus 24 is 40. Then this is equal to 4 plus minus the square root of 40 divided by 6. We need to find the divisors of 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 5 is 1. Okay? So 40 can be written as 2 cubed times 5. We are going to use it here, but instead we are going to write it in this way. This is equal to 4 plus minus the square root of 2 squared times 2 times 5 divided by 6. And now, continuing working on this exercise, it is equal to 4 plus minus this 2 squared here. I pass to outside of the root. 2 times the square root of 10 divided by 6, okay? And as there is a plus minus sign here, there will be 2 roots. X1 is equal to 4 plus 2 times the square root of 10 divided by 6, and x2 is equal to 4 minus 2 times the square root of 10 divided by 6. We can factor out a 2 here, then this becomes 2 plus the square root of 10 divided by 3, and this is equal to 2 minus the square root of 10 divided by 3. These are the roots of this equation. Due to the negative sign here, we conclude that this x1 is the greatest root of this equation, okay? We are going to use this for m, alright? Let me clear the board here for more calculation. We've discovered that m will be equal to 2 plus the square root of 10 divided by 3. We are going to use this value for m in this equation here. 3 times 2 plus the square root of 10 divided by 3 minus 2 squared, okay? 3 times 2 plus the square root of 10 divided by 3 minus 2 squared. We can simply cancel these guys here, okay? Because it is the same number multiplying and dividing, and we find that it is equal to 2 plus the square root of 10 minus 2, and this squared. Observe that 2 cancels with negative 2, okay? And this is equal to the square root of 10 squared, and this is equal to 10, okay? Thus, the solution of the exercise is this. We found the roots of this equation. The exercise required us to find the greatest root of this equation, and we found this. We used this in this equation here, and applying this in the equation, we found that the solution is 10, okay? And this is all for exercise number 3. Let's go to the next exercise. Exercise number 4. It is known that m is an integer greater than 5, and that the equation x squared minus 10x plus m equal to 0 has 2 distinct real roots. Thus, what is the number of possible values for m? Alright, my friends, this is the exercise. Let's go to the solution. Let's remember the quadratic formula. The quadratic formula says that x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a, okay? This is the quadratic formula. For this equation to have 2 distinct real roots, Observe that we have here a square root, alright? We have here the square root of b squared minus 4 times a times c, okay? Observe this term. For this to be real, we need to have a positive number here, a positive real number, because the square root of negative numbers is not real, it is imaginary. Then as a consequence, b squared minus 4 times a times c has to be greater than 0. Okay? This is the condition of this exercise. For x to be two distinct real roots of this equation here, this term here has to be real. Okay? For this to be real, it has to be greater than 0. b squared minus 4 times ac has to be greater than 0, because if it is less than 0, then the roots are complex, not real. Alright, this is the condition of this exercise. b is negative 10. Negative 10 squared, a is 1, and c is m. Negative 10 squared is 100. Okay? I pass this negative 4m to the other side, it becomes positive. And I pass this 4 dividing. 4 is multiplying m. When I pass to the other side, it passes dividing. $100 divided by 4 is 25. Okay, 25 has to be greater than m, which can be rewritten as m has to be less than 25. Okay, m has to be less than 25. As m has to be greater than 5, the exercise imposes this initial condition: m has to be greater than 5 and less than 25. These are the conditions. One was imposed by the exercise, the other we just discovered. As m has to be greater than 5 and less than 25, and as the exercise imposed that m is an integer, then m is greater than 5 and less than 25. Okay? How many numbers are there between 5 and 25? Integers. 5. 25 minus 5 is equal to 20. But observe that they don't belong. It is not equal here, okay? It is only less than and greater than, okay? Minus 1, it is 19, okay? It is 19. Consequently, the number of possible values for m is 19. Alright, my friends? This is all for exercise number 4. Let's go to the next. Exercise number 5 now. What is the sum of the squares of the roots of the equation x squared minus 6x plus 2 equal to 0? Okay, my friends, this is the question. Let's go to the solution. One of the methods that can be used to find the sum of the squares of the roots is to firstly find the roots using the quadratic formula. Okay? This is one of the methods that can be used. There is an alternative way, but we are going to postpone it to another exercise. We are going to use the quadratic formula. The quadratic formula is, as you can remember, x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a. Remember that b is this. In this case, b is negative 6. Negative 6 is positive 6 plus minus b squared. It is the square root of negative 6 squared minus 4 times a is 1 and c is 2 divided by 2 times a, 2 times 1. X is equal to 6 plus minus the square root of negative 6 squared is 36 minus 4 times 2 is 8 divided by 2, and this is equal to 6 plus minus 36 minus 8 is 28 divided by 2. Observe that we can write 28 in this way. 28. Find the divisors of 28. 28 divided by 2 is 14. 14 divided by 2 is 7. 7 divided by 7 is 1. Thus, 28 can be written as 2 squared times 7 these two I can put out of the root. 6 plus minus 2 times the square root of 7 divided by 2. Okay? There will be two solutions. Observe this plus minus sign. There will be two solutions. x1 is equal to 6 plus 2 times the square root of 7 divided by 2. This is equal to, I divide here and here by 2. It is 3 plus the square root of 7. And the second solution is, using the negative sign, 6 minus 2 times the square root of 7 divided by 2. And this, similarly, I divide here by 3 and here as well, okay? Remember, 6 divided by 2 is 3, 2 divided by 2 is 1. Okay? These are the roots. Now that we know the roots, we simply square them and sum the squares as the exercise requested. x1 squared plus x2 squared is equal to 3 plus the square root of 7 squared plus 3 minus the square root of 7 squared. Okay? Developing these products here, we find 3 squared is 9, plus 2 times this is 6. 6 times the square root of 7, plus the square root of 7 squared, which is 7, plus 3 squared is 9, minus 6 times the square root of 7, plus the square root of 7 squared is 7. This cancels with this. This is positive and this negative. We have 9 plus 9 and 7 plus 7. 9 plus 9 is 18. 18. 7 plus 7 is 14. And this is equal to 32. Thus, the sum of the squares of the roots of this equation here is 32. Alright, my friends, easy, isn't it? What do you think? Alright, and this is all for exercise number 5. Let's go to the next. Exercise number 3. The equation x squared plus bx plus c equal to 0 has 3 and 5 as roots. Then, what is the value of b plus c? Okay, my friends, this is the exercise. Let's go to the solution. Okay? Observe that if 3 and 5 are roots, then the equation can be written as, alright, for any equation, for any quadratic equation, x minus x1 times x minus x2 equal to 0 will produce the original equation. We can multiply the roots in this way here, and we find the original equation. This is what we are going to do, okay? Consequently, if we multiply x minus 3 with x minus 5, we find the equation that we want. X times x is x squared, x times negative 5 is negative 5x, negative 3 times x is negative 3x, and negative 3 with negative 5 is positive 15. And in this way, the equation that we are looking for is this: x squared minus 8x plus 15 equal to 0. B multiplies x, b is equal to negative 8. C is the independent term. It doesn't accompany x. C is equal to 15. The exercise wanted us to calculate b plus c. B plus c is equal to negative 8 plus 15, and this is equal to 7. Okay, my friends, this is the solution of exercise number 6. Let's go to the next. Exercise number 7. If m and n are the roots of x squared minus 6x plus 10 equal to 0, then find 1 over m plus 1 over n. Okay, my friends, this is the exercise. Let's go to the solution. Observe that for any given quadratic equation, we have 2 roots. They can be distinct or equal, but in the general case, they are two roots. We shall use that the sum of the roots is equal to negative b over a, and the product of the roots, x1 times x2, is equal to c over a. Okay? It is easy to demonstrate. Alright? I can demonstrate one of them to you, and you can find the other. Alright? Observe that we can use the quadratic formula to demonstrate this. Okay? Observe that one of the roots is this. Okay? Let's do it. Let's demonstrate. Okay? x1 is going to be negative b plus the square root of b squared minus 4ac divided by 2, and the other is plus negative b minus the square root of b squared minus 4ac divided by 2. Okay? 2 times a, sorry, here 2 times a. As we did before, alright? Observe that they have the same denominator. Then this positive term here cancels with this negative term, and we end up with negative 2b divided by 2a, and this is equal to negative b over a. Okay? This is how we demonstrate this. We can try yourself to prove this. Okay? Just to give you an idea on how to demonstrate this, we are going to use this. Alright, let's use this. x1 plus x2 is equal to negative b. b is negative 6, negative 6 is positive 6, divided by a. a is 1. Then this is equal to 6. x1 times x2 is equal to c over a. c is equal to 10, and a is equal to 1. Then this is equal to 10. Okay? Now we work on this. 1 over m plus 1 over n is equal to, observe that m and n are the roots, okay? We take the lowest common denominator here, m. n divided by m is n. mn divided by n is m. Then we have what we need here. This is the sum, and this is the product. The sum is 6, and the product is 10. Okay? 6 divided by 2 is 3, and 10 divided by 2 is 5. And this is the solution of this exercise. The exercise wanted us to find 1 over m plus 1 over n, and we use this alternative way. I demonstrated to you how we find this negative b over a, and I invite you to try to demonstrate this in your house. Using this here, we find the solution of the exercise. Okay, my friends? And this is all for exercise number 7. Let's go to the next. Let's go to exercise number 8. Exercise number 8 now. Consider the equation 2x squared minus m minus 1 times x minus 2m minus 3 equal to 0. Letter A, if the roots are symmetric, what is the value of m? Okay, my friends, this is the exercise. Let's go to the solution. The roots are symmetric when xv is equal to 0. xv is equal to 0. Okay? If the roots are symmetric, xv is equal to 0, in which xv is the x-coordinate of the vertex of the parabola. Okay? We've got a parabola here. Okay? They are symmetric if this is xv and this is yv. Alright? The roots are symmetric when xv is equal to 0, in which xv is the x-coordinate of the vertex of the parabola. Alright? And we know that xv is equal to negative b over 2 times a. Okay? We can find xv in this way. For us here, b is this. Okay? So b is equal to negative, I pass this negative side inside, alright? Minus m plus 1 divided by 2 times a. 2 times 2 is 4. xv is equal to, now I change the sign again, m minus 1 divided by 4. And this has to be equal to 0, okay? You can understand it without changing much the sign. Simply cancel this with this, okay? Then you simply take this here and put here, alright? And in this way, m minus 1 has to be equal to 0 and m equal to 1. This is the value of m for which the roots are symmetric. Okay, my friends, this is letter A. Let's go to letter B. Letter B now. If one root is the inverse of the other, what is the value of m? Alright, my friends, this is the question. And to solve it, we need to remember that x1 plus x2 is equal to negative b over a, and x1 times x2 is equal to c over a. And as the exercise imposed, x1 has to be the inverse of x2, okay? This is the condition of the exercise. The exercise stated, if one root is the inverse of the other, what is the value of m? Alright? Then we are going to use these conditions. x1 plus x2 is equal to, where is b? b is here, as we observed previously, m minus 1 divided by a is 2. And x1 times x2 is equal to c is equal to, I inverted the sign here because of this negative sign, I inverted the sign here, 3 minus 2m, and I divide by a is 2. We can use this, okay? Instead of using this, we are going to work on this, okay? Let's use this and see what we get. One over x1 times x1 is equal to 3 minus 2m divided by 2. Okay? Let's forget this and work on this and see what we get. If we don't arrive at anywhere, we use this to see what we can do. Observe that as the exercise imposed, x1 is the inverse of x2. Then, in the place of x2, I can put 1 of x1 here, and I can cancel this guy with this guy, and I find that 1 is equal to 3 minus 2m divided by 2. I pass these two dividing, multiplying here, 2 is equal to 3 minus 2m. Passing here, this to this side, 2 minus 3 is equal to negative 2m. 2 minus 3 is negative 1. And I find ultimately that m is equal to a half. So this is the value of m. This is the value of m when the one root is the inverse of the other. We didn't even need to use this. I advise you to memorize this because it can appear in an exam, and this can facilitate you solve an exercise. But here we didn't need to use this. We used this. We used this to solve this exercise, and we found a half. Alright, my friends, and this is all for exercise number 8. Let's go to the next. Okay, my friends, let's go to the last exercise. Let's go to exercise number 9. The product of the roots of m plus 2 times x squared plus 4x minus m plus 1 equal to 0 is negative 3/4. Thus, what is the sum of the roots? Okay, my friends, this is the exercise. Let's go to the solution. As we saw in the previous exercises, we shall use again that the sum of the roots is equal to negative b over a, and the product of the roots is c over a. The exercises say that the product of the roots is this. So we know that it is negative 3/4, okay? This is the condition, the initial condition of this exercise. Observe that x1 plus x2 is equal to b is 4. Then this is equal to negative 4 divided by a. A is equal to m plus 2, okay? Observe also that x1 plus x2 is equal to c over a, where c is this, negative m plus 1 divided by a is this, m plus 2, okay? This is a, and this has to be equal to negative 3 over 4. We cancel this sign with this sign. Negative with negative is positive. Then we find that m plus 1 over m plus 2 is equal to 3 over 4. Isn't it? Do you agree with me? Thus, 3 times I pass this multiplying, 3 times m plus 2 is equal to 4 times m plus 1. Isn't it? Do you agree with me? 3 times m plus 2 is equal to 4 times m plus 1. We develop 3m plus 6 equal to 4m plus 4. Solving this, 4 minus 3 is 1. I pass this, did you understand? I passed this to this, it becomes 4 minus 3. And now I pass this to this side, it becomes 6 minus 4, and it is equal to 2. Then the value of m is 2. With the knowledge of the value of m, we can find the sum of the roots. x1 plus x2 is equal to negative 4 divided by 2 plus 2. And this is equal to negative 4 divided by 4. And this is equal to negative 1. Alright, this is what the exercise wanted from us. What is the sum of the roots? The sum of the roots is negative 1. Okay, my friends, this is all for exercise 9, and this is all for this video. I hope you enjoyed it and learned from it. I am a teacher, guys. If you want to book a lesson with me, use my WhatsApp number. Goodbye.